Good afternoon, Mr. Garpy. Today I'll be explaining 5.7 to 5.8. So we're going to start out with 5.7, the sampling distribution for sample mean, the sampling distributions for sample means, which is the overall topic. So I'm going to give you a question and I'm going to go step by step on how to actually solve this question. So let's get straight to it. The average weight of a Costa Rican man is 165 pounds and has a standard deviation of 3 pounds. 3 pounds. Suppose that we took a random sample of n equals 35. What is the probability that the sample mean is less than 164? Okay, so one thing you do gotta watch out for is the central limit theorem, which means that our sample size has to be over 30. Here we have the green light because it's over 30, it's actually 35. It can be 30 or more, it can't be less than 30. So the first thing you actually want to do is find the sample's standard deviation, which is standard deviation over the sample size, meaning that is 3 over root of 35, okay, which is going to give you 0.504. So now that you have the standard deviation, you actually want to find the z-score for 164. So you do 164 minus 165 divided by 0.504, which is going to give you negative 1.972. That score you give is how many standard deviations away it is from the mean. So because you have that number, you actually have to find what percentile it's in. Finding the standardized score, the z-score, which is 0.0244, which is about 2.4%. So because of this, it's extremely unlikely that we would sample a mean that is less than 164, and we can see it over here with the graph. Here, if we see the graph, it's very unlikely. It's at the complete edge of it. So now we move on to 5.8, sampling distributions for differences in n sample means. So the average height of a man is equal to 171 centimeters with a standard deviation of 7 centimeters. For a woman, the average height is 167 centimeters with a standard deviation of 6 centimeters. Suppose that we collected data from a random sample of n equals 50 from each gender. What's the probability that the mean height of a woman being greater than the mean height of a man? So it's a lot of words, but we'll get there. So the first thing I would do, and typically what you would do, is you would grab the two means and you would compare them. So you subtract the woman's mean minus the male's mean. You do this because you're finding out the probability of women's having a greater mean. So you put the woman's first, which gives you a negative comparison of the means, which is 167 minus 171. So now you want to find out the standard deviation, and you kind of do the same thing, but key thing to remember is you actually don't subtract the two standard deviations, you add them, giving us a standard deviation of 1.304. So now you might be wondering, how would I figure this out? So now you want to find out the z-score, okay? So you're going to do 0 minus 4 divided by 1.304, which is going to give you 3.06, right? And then you want to grab the z-score, the standardized score, which is 0.989 minus 1, which is going to be equal to 0.011. Okay, so you might be begging the question, what does this mean? So what this means, if you were to grab many samples, well, 50 people, you would typically only see a woman having a greater mean about 1% of the time, which is extremely unlikely. And we can see
at
here
the area under the graph here, it's really...
So what does this mean? So it basically means that if you took a sample of 50 males and 50 females and you ran a simulation over and over again, only about 1% of the time would you see females having a higher mean than males. Hopefully you enjoyed the presentation.